Hello, today we are going to discuss about document classification. What is document classification? Document classification is a process of assigning categories or classes to documents to make them easier to manage, search, filter, or analyze. A document in this case is an item of information that has content related to some specific category. It is also a data mining problem. Unfortunately, we can make use of the CRISP DM cross industry standard process for data mining, which according to Wikipedia is a data mining process model that describes commonly used approaches that data mining experts use to tackle problems. Document classification steps. Here, CRISP DM provides an overview of the data mining lifecycle. The lifecycle model consists of 6 phases with arrows indicating the most important and frequent dependencies between phases. The sequence of the phases is not strict. In fact, most projects move back and forth between phases as necessary. The CRISP DM model, which is flexible and can be easily customizable. For example, if your organization aims to detect money laundering, it is likely that you will shift through large amount of data without a specific modeling goal. Instead of modeling, your work will focus on data exploration and visualization to uncover the suspicious patterns in financial data. And CRISP DM model allows you to create a data mining model that fits your particular needs. In such a situation, the modeling, evaluation, and deployment phases might be less relevant than the data understanding and preparation phases. However, it is still important to consider some of the questions raised during this later phases for long-term planning and future data mining goals. The first phase is business understanding. In this, any good project starts with a deep understanding of the customer's need. Data mining projects are no exception, and CRISP DM recognizes this. Business understanding. In this phase, we need to understand the project objectives and requirements from a business perspective and then convert this knowledge into a data mining problem definition and a plan designed to achieve the objectives. Business understanding is broken down into 4 tasks together with its projected outcome or output in detail. Simply put, the business understanding phases goals to. Aside from the third task, the other 3 tasks in this phase are foundational project management activities that are universal to most projects. The first task is determine business objectives by understanding from a business perspective what the client really wants and the company wants to accomplish and identify what are the criteria to gauge business success or project success. And the second task is access situation by checking what are the needs to be done in terms of resources, the requirements, assumptions, and even the constraints of the project, the risks and terminologies used and to be used. Lastly, the cost and benefits of the project. And the third task is determine data science goals by describing what your data science team or data scientist goal and objectives are for the project in terms of technical and defining the data science success criteria. And the fourth task is produce project plan by describing the plan intention for achieving the data science goals. To be able to achieve the business goals, create a project plan with the specific project stages, the duration, resources needed, and even the cost, and to have an initial assessment of the tools and techniques to be used. While many teams hurry through this phase, establishing a strong business understanding is like building the foundation of a house, absolutely essential.
After the data understanding, the next step is data preparation. Data preparation. In this stage, we will prepare the data for classification using information acquired from the observation phase. We will do the following steps for data preparation: cleaning, text tokenization and transformation, and attribute selection. Cleaning and tokenization. Both cleaning and tokenization can be done using the string to the vector filter in the weka. Tokenization. Tokenization is to make the provided document classifiable by using machine learning. We need to extract the features which is converting from a normal text to the set of features that can be used by the machine learning algorithms to discriminate between the con and non-con. In our case, this will be done by STWV by assuming that each word vector in a document is a feature and the number of occurrence in each instance is a feature value. Modeling, classification, and evaluation. In this phase, we select the required classifier algorithm and run the dataset, and we go with the classification. There are many classifiers algorithms to run for different types of datasets according to your concern. Example like Navi bias, JRIP, etc. After the classification, the result get evaluated with the given text data and run classifier algorithm and we get the result. Next, we'll implement the using weka tool for text classification. weka tool for a document classification. This works shows the use of weka, a tool that implements the most common machine learning algorithm to perform a text mining analysis on the set of documents. Applying these methods requires initial steps where the text is converted into a structured format. Both the processing phase and the analysis of the transformed data sets using classification and clustering algorithms can be carried out entirely with this tool in a rigorous and simple way. The work describes the construction of two classification models starting from two different sets of documents. These models are not meant to be good or realistic, but just illustrate how weka can be used for a text mining analysis. Later on, we'll explore into the weka and we'll start doing a started doing with an example. Data sets. Let's take the two data sets from our document classification. One is trained data set and another is text data set. For data understanding, we'll inspect the data to decide which steps are needed to prepare for the data classification. Attribute selection. There are many ways to spot the best attribute. I will list them here for your information, but for the sake of the tutorial, the provided attributes will be left as is. Classification. Now we will now do classification will by using the Navi bias algorithm and the final step of evaluation. Now let us see the weka tool and explore with an example.
Hi, here we're going to use the weka tool, how we are going to do the document classification. For this, we are going to open the weka. We need to download first. After downloading, we can see here how we open the weka. And next, we're going to explore. For this, we need to first know what document we are using and what classification we are going to use for the business understand. For the business understand. For this, I want to see what is in the document. So the document is will be in the ARFF format. The downloaded documents or datasets is I kept it is in my download. You can see this AR format. For this we will use the train dataset. When we open and see the train dataset, what is inside, you can see over here the relation and the attribute document and the attribute class. We have the student, faculty, project, course, everything. And these are all strings we are first going to convert into the word by using the string to word vector. And later we're going to do the document classification in detail, and we can get the each and everything in detail. We can be visualizing each and every word in detail. See, first just we go and explore it. Here we will do the explore. Here we use the explorer, and we will use to open the file as I show you the train data set. Here we go and we open it. After that we're going to see here the class I select. You can see the label count and the weight, and we can visualize all over here. And the next we're going to in-depth visualization. We are converting the all string into the word, as I said you before, string to word vector. And after that you need to apply it. The each string is converted into the word. Here you can visualize each and every word in detail. Here you can see, here is the name, this is the word, and here is the missing is 0, and the type is numeric, unique is 0, and here is the visualization of the word. This is the deep visualization of each word in the document, how we here. And next we go for the select attribute. In the select attribute we need to select some of the attributes. I want to show you each in detail. For this we need to use this, and for this we need to use the rankers. According to the ranking we select the attributes. And for this ranker algorithm, you can see here that the ranker the and next we use the I want to use the two class for links. And after that I'm going to select the normal class, and after that I'm going to apply it, start the document classification. Here you can see the status, it is running. Here you can see each and every ranking of the document, ranking, and here we're going to select the attribute according to the ranking. Here I'm going to choose the YACC and numerous as my attribute. So after this I'm going to select for the associate. Here you can choose the appeal algorithm for the selection of the associate. Here as you can see it, and the main we are going to at least we are going to classify. For this we are going to use the algorithm. Here I want to use the Navi bias algorithm for the classification of your document. Here if you see it, here you can use the do not check capability and each numerical places and everything. Don't do any changes over here. And next we have, I showed you in the starting, we have a test data set. Here we need to select for it. As I see, open it, and here the class I am going to use is as we need to select for the class, not the word, and then and by clicking on the start you will see the status okay. You can see in the first, from the first you can see here the Navi bias classifier we used, and here you can see the attribute and the standard deviation and the mean and the weight sum and the precision of the each attribute in detail. And if you see the summary of the document, here you can see the correct classified instances and the kappa statistics and the mean absolute error, everything in detail. If you see the class and everything of measures, and the here you can see the confusion matrix. This is the detailed document classification we are seeing. This is how document classification we can perform by using the weka explorer tool. This is what I want to explain about the weka explorer, and this is how we do all the things using the weka tool. That's it. Thank you so much.